Okay, in this lesson, we're going to talk about solving trig functions or solving trig equations. So we're going to look at four equations that have trig functions in them, and we're going to use our basic trig identities that we're working on learning and memorizing to solve these equations that we couldn't without those identities. So two things to note when solving trig equations. First one. Never try to solve by dividing by a trig function. So dividing and never and trig function are our key words in that statement. Okay, so anytime we've got an equation with trig functions in it, if we're trying to solve it for x, none of our steps to get x by itself will involve dividing by a trig function. Okay, we can multiply, we can add, we can subtract, we can factor, but we can't divide. Okay, number two, always check to make sure your answer works. So when we get a set of answers, a set of angles, we want to plug them back into our original to make sure that we don't have any extraneous solutions, because they will pop up every now and then. All right, let's look at some examples. This one says solve each equation on the interval 0 to 2 pi. Okay, and it's hard to see that. Let me rewrite that. The font is kind of funny. Including 0, not including 2 pi. Okay, so any angle in our unit circle from 0 to 2 pi. So number one, cosine cubed of x over sine of x equals cotangent of x. We want to solve for x. Okay, so the first thing I see is this sign in the denominator, and if I can, I want to get rid of fractions. So I would typically start by multiplying both sides by sine, but before I do that, I see that I've got cotangent over here. Recall one of our quotient identities that cotangent is the cosine of an angle over the sine of an angle. So if I rewrite cotangent as that quotient and bring down the left side my function or equation. Now I've got sine as the denominator of both of my sides of my equation, so I can multiply both sides by sine of x now. Okay, so sine of x over sine of x makes 1. Sine of x over sine of x makes 1. So we're left with cosine squared of x equals cosine of x. Okay, so we're looking for some angle whose cosine of that angle squared is the same as the cosine of that angle. Okay, but again, we want to solve for x algebraically. So at this point, I want to get all of my trig expressions on one side of my equation. So I'm going to go ahead and subtract this cosine of x from both sides. So on my left side, I've got cosine squared of x minus cosine of x. And on my right side now, I've just got 0. Now, the benefit of having 0 on the right is that now on the left side, we've got two terms that both have a cosine of x factor. So we can factor out that cosine of x. So if we factor out that cosine of x, now we've got cosine of x times cosine of x minus 1, and now we've got a product on the left side. So anytime you've got a product that equals 0, recall the zero product property from algebra that says that any two or more numbers times themselves equaling 0, one of those numbers has to be 0. So either cosine of x has to be 0 or cosine of x minus 1 has to be 0. So this is the same method that you used in Algebra 1 when you solved quadratic equations by factoring. Okay, when you kind of factored them into two binomials or whatnot, and set each one equal to 0. This is a zero product property. So cosine of x is 0. If we want to solve for x, we want to convert it to inverse cosine of 0 is x. And then over here, if we add 1 to both sides, then the cosine of x is 1. So we want the inverse cosine of 1, which is our x value. So we're looking for what angle has a cosine of 0. Okay, so go into our unit circle. What angle has a cosine of 0? Cosine is our x. Okay, so here we've got pi over 2, which has a cosine of 0, but also 3 pi over 2 has a cosine of 0. So we want to include both of those as possible solutions. So for our for this guy, x is going to be pi over 2 and 3 pi over 2. Okay, so now we're looking for what angle has a cosine of 1. Okay, going back to our unit circle, cosine of 1, cosine of -1. We want just a cosine of 1. So 0, remember 2 pi is not included in our domain. 0 is the only angle that has a cosine of 1 within our range. Oops. So this factor is going to give us the possibility that x equals 0. Okay, so here's our 3 possible solutions. Now, again, going back up to the top, we didn't divide by a trig function. Now we want to check to make sure our answer works. Okay, so now here's the kicker. We've got a fraction with a trig function in the denominator. We know that we can never divide by 0. So we want to make sure none of our solutions allows this denominator to be 0. So let's plug in our functions, and that's mainly the one that we're looking at, just that sine of x in the denominator there. So if we plug in, we've got pi over 2, 3 pi over 2, and 0. So the sine of pi over 2. The sine of pi over 2 is 1, so we're safe there. The sine of 3 pi over 2. Okay, 3 pi over 2 here. The sine is -1, so we're safe there. And 0 is our other possible solution. The sine of 0 is 0. So that is not okay. 0 turns out to not be a solution because of the fact that if we plugged in 0 into our original equation, the sine of 0 is 0, and we cannot divide by 0. So our final answer for number 1, x equals pi over 2 or 3 pi over 2. Okay, or we can write it as a set, pi over 2 and 3 pi over 2. Okay, let's look at our second example. Okay, 2 cosine of x sine of x minus cosine of x equals 0. Okay, so now we've already got this 0 on the right side of the equation, so I don't want to mess with that. Let's look at the left side. Notice both of these terms have a cosine factor, so I want to go ahead and factor out that cosine of x. So I've got 2 sine of x minus, and make sure you put a 1 placeholder there, still equals 0. Okay, now again, we've got the product of 2 values equals 0, so let's split them up. One of them's got to be equal to 0, at least one of them. So we've got cosine of x could be 0, or 2 sine of x minus 1 could be 0. Okay, we just solved for cosine of x being 0, and we found that when our cosine is 0, we've got pi over 2 and 3 pi over 2 as our 2 possible angles in our range. So starting off the same way as our last problem, solution-wise. Okay, now let's look at this one. We've got 2 sine of x minus 1 equals 0. So let's solve for this sine of x. If we add 1 to both sides, and then we divide both sides by 2. Oops, that should be a 1, shouldn't it? 1. sine of x equals, divided both sides by 2, 1/2. So now we're looking for x to be the inverse sine of 1/2. In other words, what angle has a sine of 1/2? And now be careful, because if this were just all by itself on its own problem, the range of this would just be from 0 to pi over 2 and 0 to negative pi over 2. But since we were given this to be the interval of angles that we're looking at, so this overrules what we know is the range of our inverse sine function. So we're just looking for what angle between 0 and 2 pi has a sine of 1/2. So let's go back to our unit circle. Sine of 1/2 here, and then if we go keep that same y value, then sine of 1/2 here. So we've got pi over 6 and 5 pi over 6. Okay, so those are our two solutions we got from this factor. Now, since we don't have any fractions here, there's no way that we can divide by 0. We don't have any square roots. We don't have any logs. We don't have any of those other restrictions to our domain. So if we plug in any of these 4 values, then we're going to get a good solution. So our answer is going to be the set that includes pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. Okay, number 3. I would like for you guys in your notes to work out number 3. We'll talk about it in class tomorrow. Work out number 3, and we'll go over that one together in class tomorrow. All right, let's go on to number 4. Next page, number 4 says, find all values of x that solve the following equations. Okay, note the difference in the directions. We no longer have a restricted domain of 0 to 2 pi. Now we're looking for every single angle that will solve for x. So we're going to start it the exact same way. Number 4, we've got 2 sine squared of x plus sine of x equals 1. This 1 over here, I sure would like for that to be a 0. So what I'm going to do is I'm going to subtract that 1 from both sides. And we're going to get 2 sine squared of x plus sine of x minus 1 equals 0. So now what kind of an equation does that sort of kind of look like? Okay, we've got a squared term, a term of the first power, and then we've got a constant. It looks like a quadratic term. Okay, when we did our little mini factoring unit at the end of the first quarter, we did something called u substitution, where if we let u be sine of x, and we sub in u, so we've got 2 u squared plus u minus 1, and this looks a lot more like a quadratic function. And again, if you can eyeball it, and if you're good with doing a quadratic and a trig function together, you don't have to do this u substitution, but it sure does make it look easier, less frightening. So we've got a trinomial, quadratic trinomial. Let's see if we can factor it as a product of 2 binomials. So 2u, I'll bet, is going to be the first term, and u is going to be the first term of my other binomial. We've got a 1 here, so I bet I'm going to have a 1 and a 1. I've got a negative here, so I'm going to have different signs. The bigger one's got to be positive, so I'm going to have a plus here, a minus here. All right, if you're a fan of factoring using the box, then by all means, go for it. So now we've got the product of these two factors equaling 0. 0 product property. 2u minus 1 has got to be 0, or u plus 1 has got to be 0. Okay, solving for u, add 1, divide by 2, u is 1/2. Solving for u, subtract 1, u is -1. Now, again, we're not trying to find u, we're trying to find x. So let's go ahead and sub in sine of x, sub back in sine of x. So this u is the same thing as sine of x. Same thing as sine of x. Alright, so back into the world of trigonometry, we're looking for what angle has a sine of 1/2. Going back to our unit circle. Sine of 1/2, we've got pi over 6, 5 pi over 6. Okay, that's all on our unit circle. So let's start with those. Pi over 6, 5 pi over 6. But the direction said find all angles. So we don't just want the angles that are on our unit circle, we want every single angle. So what we need to do is, since pi over 6 and any coterminal angle with pi over 6 has the same sine value of 1/2, then we need to include any coterminal angle. So the way we do that is by adding 2 pi k. Okay, so that'll include, we can add on any revolution to pi over 6 and we'll get a coterminal angle with pi over 6. Okay, same thing with 5 pi over 6. If we add or subtract any revolution, any whole revolution, then we're going to get a coterminal angle. So again, we want to make sure, just like we've done with our graphing, anytime we use k, we want to restrict it to being an integer. Alright, so now let's go over to our other factor, sine of x being -1. So back to our unit circle. Where is sine -1? 3 pi over 2. That's our only angle on our unit circle. So 3 pi over 2. And again, it's not just 3 pi over 2. It's 3 pi over 2 and any coterminal angle with 3 pi over 2. So our solution is all of this good stuff right here. These are our 3 possible solutions. Okay, and then don't forget your k is an element of the integer. Okay. Example number 5 and example number 6, I would like for you to do in your notes on your own. Practice these. Solve for x. For these last two, make sure you include all possible angles. And be careful of ones that don't exist. And we'll go over these in class tomorrow. So solving trig equations. You're going to need your unit circle as a reference. The trig cheat sheet has one in it. That's good to have handy in your notebook. Remember, never solve by dividing by a trig function, and always plug your answers back in to make sure that it works.